Okay, so now we're going to do mock interview 2 with Sam, but this time we're going to do a stronger version. So again, if you would like to watch the raw footage instead of watching the voiceover, it's linked here, but I'm going to watch it here, speed up some parts. This one is even
All
longer,
right. Hi, Sam. How are you doing?
Hi,
so there'll be even less of it than in the previous ones, so we'll kind of skip over some stuff.
I'm doing great so far.
Great.
Whoops.
All right. Hi, Sam. How are you doing?
Hi, I'm doing great so far.
Great. Okay. So I sent you the code prompt. So do you have it ready and the file
Yes.
ready? You can go
Yep.
ahead and share your screen.
Okay, here we go. Share. All right. Yep. Should we go?
Uh, Go ahead and get started.
All right, cool. So it's asking for two strings set to be anagrams of one another if you can turn the first string into the second by rearranging these letters. And then your job is to write a function that takes two strings as inputs and determine whether they are anagrams. Of course, I'm just going to do that right now. Just get that out of the way. I'm going to create a function. Of course, it's going to be Boolean, and it's going to be called like something anagrams, and then string. We're going to call it because we have just two different strings. The first string.
So he's taking the approach of going right to a
First, and then
function declaration
second,
line to make sure that he
second string target.
knows how to approach the
For now, we're
problem.
going to keep it return false.
Or
And
he's
for now,
just
let's
writing the
call it,
function itself.
just to have it. Actually, for now, let's not call it because we don't have the later
But
on once
he's
I'm done
doing
implementing
a
the
good
function, I'm
job
actually going to write some cases.
putting in the right
I think
parameters
so.
using
No,
good
let's
function name.
not do that. So I just want to talk through it. We have two strings, and we're going to try to see if they match each other. The first thing when I saw this, obviously, was just talk about the first way is just talk about go about having different kind of permutations, and then see if they match up with the words that are given in the second strings. And if that happens, if that goes through, then it's of course return true. Else it's going to be return false. It's going to be some sort of recursion with a base case. If they all match up, of course, just return true.
So
But
your idea is to find all the permutations of one word and see if it matches
Yeah.
like the original word of
Yeah.
the second word. Is that
yeah,
what you're saying?
yeah,
Okay.
and I think that's a good first idea. But the issue with it is that it has a big old complexity of n factorial, and I think that'd be way too much. The second one,
So he's acknowledging this idea that like you could basically recurse to get all combinations of one of the words, which is easiest to do recursively, just like you know how you do the factorial. Uh, Actually, it has nothing to do with that, but you know, recursively you can find combinations of things quite cleanly. But he's acknowledging it right away that it's way too complex.
I thought of two other more. The second one would be just sorting out, doing a sorting kind of scenario where you sort out the words and then you just keep checking each single word.
Sorting out each word, both words.
Yeah, just sort out the words and then check if they are equal in like each single character that's given. But I think that's also a bit hefty. I think, yeah.
And so what's the complexity? Like, what's the best you can do with sort for complexity? What's the best sorting algorithms?
I think that's actually n log n because you're sorting it and then going through each one. But
do you know of some sorting algorithms that are n log n?
Sorting algorithms. The merge, the kind of like divide and conquer kind of sorting algorithms.
Okay, so if you need two sorts, it would be n log n, and then the comparison between the two strings. Okay, so yeah, there is definitely a more efficient way to solve this. So what can you think? Your two.
So I'm acknowledging that he has identified a more efficient way to solve the problem than n factorial, which is really that hard, which is sorting the two words so that the characters are in sorted order, and then knowing that once they're sorted, then if they're anagrams, they'll be equal. And that's great because that's a really easy code to write, right? That's like 3 lines of code: call sort, do a compare. And he's acknowledging that that must not be the solution because that would be very easy to write, right? So he's getting feedback from me. He's saying like, that seems like a solution, but like, why are you making me write that? And then I'm telling him, you know, no, there is a faster way.
Two initial ideas are fine, but can you think of a better way to do it?
Yeah, actually. So I was just thinking about it right now, and it just hit me. So one of the actually the only way was that we would have some kind of a container that contains 26 just elements in it, which are going to be the alphabetical letters, and then we're going to kind of do some kind of a frequency map where whenever we find a single word from the, we're going to look at the first string. Every time we find a single word, we're going to go to the index element, and then we're going to update the frequency of how many times we found this
When you say
letter.
a single word, do you mean a single character?
I meant
So he's nervous, so he's saying words wrong, but it's okay. I still understand what he's saying. I'm just clarifying. He's, you know, saying it again, trying again. That's totally fine.
single character. Yes.
Okay, got it.
Yeah.
So you have a list of some sort, some container. There's 26 spots, and what's each spot?
Each spot is it's like an integer, of course, but like they correspond to the alphabetical letters, with the first index being A and then the last one being C.
Okay.
So let's say our first string is just saying ABC, then it's gonna, well, let's say AAC. So the first two letters, A being A, that's gonna.
He's doing a great job of explaining some examples right here. and using them to explain what he's going to use this as implementation. One way that he could improve this is by writing down these examples in his file so that I could follow along as he's writing it. It would also help him than just thinking about it all verbally, but he's doing a really great job.
Now go to the frequency container. It's going to increment the frequency of the, it's going to update and then increment the first index of A twice because we have them both. And then of course there's a C, so it goes to the third index, so it would be 2, and just update it, increment it by 1. And
so you do that with one word, so that you have how many instances of each character there are in the first word, and then how do you know that the second word has that?
Okay, so that's the first part, and then comes the second part. Also, we're going to be looping through the string of the second word.
So I'm really talking through this with him. I'm trying to make sure that I understand that he knows how to solve the problem before he even goes into code. This could take a couple different paths depending on how big of a code they're having you write. But for now, I'm like, okay, you're making a frequency map, but what are you going to do with it after you make it?
And then the second word is going to be the same kind of way, except we're going to be decrementing. So we're going to look through each single letter, and while we go through each letter, we're going to go to the frequency map that we made, and we're going to just keep decrementing until
bit, and then
maybe
he
at some
starts coding. So let's move on to where he's coding.
One sees, and I'm just going to.
So he's building his frequency map.
26.
Oh, I see, because you always know it will be exactly 26. You're not considering words that have any other characters other than the 26.
Yep, actually.
So he runs into a little problem here. Basically, it's a syntax problem. He's using Visual Studio, so he is getting compiler errors automatically, right? And so it's saying like, oh, this won't work, this won't work, this won't work, and it's really hanging him up a little bit. And this is the challenge of using an IDE with a compiler when you're coding.
Does not like that for some reason.
Why is it underlining frequencies when you do that? When you had brackets there,
because actually both of us are wasting some time.
Expected,
he's
so it's saying it
expected
a semicolon. I would expect
that
10 minutes semicolon would be here, but
which is fine.
Yeah, no, I'm not really sure.
But I mean, you can just do an int star.
I think he spends a couple minutes on this trying to get the
that's
syntax.
True, because an integer, when you're trying to make an array, it's going to be a pointer. Yeah. So in essence, it is a pointer. I was so used to just doing C++.
Another thing
obviously
is that he could just probably use a vector. He didn't ask, and so there's no reason he has to use a C array necessarily. I mean, he came up with the frequency map, so he's chosen to use a C array, and he's not getting the syntax to work when he probably doesn't even need to.
Haven't done that in a while in array. But so the first thing being is that we're going to make the base case where we just actually check if the lengths are the same. If they are not the same, then we can just return false and get it over with. So I'm going to just check the length.
So this is okay. He's moving into writing code for like a couple of edge cases. So he's like, if they're not even the same length, why are we even bothering? It's actually a really important base case because the whole frequency map doesn't work if you don't do this. However, you might want to, leave those edge cases for later in some cases. In this case, it's an okay edge case to bring up right away.
I'm not going to be checking anything. We're going to go through each single letter in the string, and we're going to be finding its index in the frequency map that we made, or frequency array, and we're just going to increment each single letter that we find in our first string. So frequencies, then we need to give it the index being first dot character at I, and then minus. And then so we're going to be doing at I minus A, because the way it works is that it doesn't have character at. Has no member character.
Oh, so you're trying to, it's okay, you could write that function later, but you're trying to find the character and then subtract off the
base kind of character.
The base character. I get the idea. You could write that function later if you wanted to, but I get the point of the function.
Yeah.
So in this part of the code,
that's fine.
he isn't really explaining how this index notation is able to pull out the right index. So what he's doing is he's getting a character, and if he subtracts off A, he'll get the right index for the alphabetical frequency map that he has. And he doesn't really explain that very well. And so that could be definitely improved. And he's also getting a little hung up on the fact that that red underline is there and it's really bothering him. He should just use the square brackets or at, which he eventually does get to. I also just asked him,
assume that we did.
Can you increment without having to initialize?
So that's going to populate our entire what is it called?
He's
map frequencies.
realizing, oh no, you can't, and he answered that question.
And then comes the next operation, which is going to now be checking the second string, and that's going to have two different things: not only decrementing, but also checking if we ever find that one case where we find a letter and the map says that there's 0 frequencies found from the first letter, and then at that point we're going to say it's going to be returning it doesn't exist. That means that a letter doesn't exist. We're going to return false. First dot length. And then we're just going to make a simple for loop again, just like the first time. Actually, sorry about that. It's second, because we're looking through the second string. Yeah. Okay. And then the first thing I'm going to check is if the letter that we found in the index in the map is 0. So if the frequencies, and then second, I'm just going to use character at for now, chart at I, and then we're going to do equals 0. That means it went to that index, found that it's 0. You can't decrement from a 0. That means there's negative characters. That's not possible. Then we're just going to return false. Else, that means that it did find more than 0, an integer bigger than 0 in that index. So then we're going to decrement.
So he has a typo here where he, again, is kind of messing up this index. You know, you need to take whatever the letter is and subtract off A, and that will give you the proper index for the map. It's, you know, really similar to making an integer array, and like you're basically like writing a hash function in order to find out which index is A, which index is B, which index is C. But he makes this he makes this bug here, and he actually never fixes it. And the interviewer pointed it out a couple times. He fixed one of them, but then he left another one, so that's okay. It's not like a crucial
thing.
So
for the C++ string library, how can you access an element in a string? Do you remember that syntax?
So
it's not char
I'm trying to lead him to fix char at, which is underlined.
Oh, yeah. I mean, I just like to use the bracket operator.
So as we keep going, you know, he moves on, and he fixes those, you know, function calls, and you'll see that he continues having
of each letter,
the
and
error
then
here.
go again
so
through the second
string. First
thing you check if the element index is 0. If it is, return false because you can't decrement to -1. Else, that means that it is bigger than 0. Then you're going to be decrementing.
Okay, do you want to run through an example code then, or an example to strings?
Yeah, of course. So that's kind of what I was actually doing now. So I'm just going to make a string.
And now I'm kind of, okay,
first
let's
equals,
test it on something. Let's get an example. And he actually works through a couple examples here, and he types them out totally okay, and he realized, oh, those aren't really good examples. I need to pick an easier one, something that's easier to trace. So he does this one first. This is a good example because it just shows that first edge case doesn't work, and so that was a really nice one to start with. And then he tests a couple other word combinations. He starts to compile, that's what you could see right here, to test his code, which I encouraged him not to do because his code is not correct, especially this line here. And so I kind of pulled him away from compiling and to just trace his code, which he started to do. Let's see, so he moves into an example that was really good. So he is like, well, let's actually have an anagram. So let's do banana and then another word that has all those same letters. And so you can see him like rearranging the words.
So now we have the first index being 2, and again,
the letters.
Now it has the integer of 2, and then A. So it's going to have integer of 3. So now we have our map being consisting of the integer,
just tested.
First of all, index A with 3 integers. I mean, not 3 integers, integer 3, because it's the frequency of A is 3, B with frequency of 1, and frequency of 2.
This is pretty tough.
Okay, so for the second
he went through and traced the code for these two words, but he really struggled with keeping track of it because he didn't type it down. He's just doing it verbally. So it would be really good if he would write the frequency map out and perhaps only pick 2 words that like use maybe the first 4 indexes or something, so that he could, you know, write out the array and actually be able to follow.
This is great. And can you just tell me what the complexity of your solution is?
Yeah. So because we have, of course, we initialize all the elements. That's fine. We have a loop that goes through the entire first string. That's an ON. Of course, also going through the bracket operator, because it's an array, you can easily just go there through O1. So the entire complexity for the first loop is just ON, going through the entire first string. And then for the second for loop, it's just going to be same thing, going to the index of an array for both of those, just O1, very simple. Also for this part, line 32, so the entire for loop is just going to be ON as well. And of course, I forgot to go through that. It's the length of a string is, I'm pretty sure one of the private members of the string is the length of it, so it's just O1 as well. So the entire thing is going to be ON.
I really like that thoroughness of his complexity. First of all, it was great. He was right on with all of it, but then he's also like, oh wait, I forgot the edge case. I need to say that's complexity too, which is a nice touch.
Which is better than n factorial and n log n, so that's great.
Yep.
Okay, well, that is great. That's the end of the interview.
So that's it. And definitely go watch some of those details that I skipped over, you know, if you're interested in kind of seeing how the testing went and whatnot. This was a really strong interview. Lots and lots of great things in it. Very, very good talking, like talked through everything. Also was really good at listening because there was a bunch of things that came up, bugs, syntax issues, and Sam really listened, and it really improved his code because he was listening. And I was giving him all sorts of tips like, oh, are you sure like that that's how you access it in the string library. He talked out his ideas before he started coding. And so we were both on the same page of what the implementation was before he even coded. It would have helped if he actually typed out some comments of that. For sure, that would be a little bit of an improvement. He was very good at talking about big O. He was always right on with it. And he was very good at like thinking of edge cases. So when he did his examples, he did ban and banana, he did banana and banana, and then he did banana with an anagram. He could have spent a little bit more time clarifying the problem before he started talking about the solutions. That would have really helped a lot. I felt like when I was watching that, I wasn't really even sure what the problem was yet, because he just kind of started jumping into solving it. But he did pretty good, and writing out the function declaration line in a couple of examples was really solid. He got too hung up on syntax and compiler errors that luckily did not waste too much of his time, but it could lead to a lot of problems. So it wasn't detrimental, but it's probably a bad habit because it could be detrimental. And that's when the testing came. That was one of the problems, is that he had a couple compiler errors, and I don't know how long that would have taken, but it wasn't necessary to write a bunch of test cases, and it would only work if it was perfect. And so relying on that is not super solid. It's probably better to trace the code. Okay, that's it.